Hello everyone, I am Mrs. Padmashri from SNS College of Engineering. Today I am going to explain about Vapnik-Servonankis dimension. In short, it is called VC dimension in machine learning. So let me explain about what is VC dimension, how it is used in machine learning concept. So dimensions. So from the word dimensions, we all know that it is something we are going to measure it, right? So VC dimension is mainly used to measure the complexity of a machine learning model. What is then the question arises, what is the complexity of the machine learning? How we can measure the complexity? Yes, it means like you can measure the complexity by just analyzing the performance of your algorithm. So how accurate your machine is working, how accurate it is producing the output. So the accuracy of the machine learning algorithm can be calculated, and also how your model is working well for unseen data. See, we all know that it works for your data set. Machine learning algorithm work for the data set, but we need to analyze if we give any unseen data or anything hidden data sets. If we give, like, the machine has to work well for the same original data set. So we need to measure the performance of the machine learning. So for all these reasons, we have a concept in machine learning which is a VC dimension. What it is V and C? V is Vapnik and C is Sebon and Keats. They are the scientists who introduced this concept in year 1970, and it has become the fundamental concept in statistical learning theory. It is a measure of capacity of a hypothesis which is said to fit different data set. The VC dimension is, again I'm repeating, it is a measure of a complexity of a model. We are going to measure the complexity of ML model, which helps us to understand how well it can fit a different data set. Here, one important concept arises: shattering. What is meaning called shattering? So, for example, if you like drop down a mirror, it just shatters into many pieces, right? The same, a shatter is, imagine that you have a hypothesis of set S. If the set S is shattered into different different subsets, we can call different subset. Say for S1, S2, S3, S4. So all these subset are from the hypothesis set. So the shattering, it is a hypothesis class, and it's set to shatter a set of data points. No matter whether we label those points or not, the hypothesis class has a function that has correctly classifies them. So for simple, I am going to explain it with simple example. Suppose I'm having a set of fruits and vegetables in my hypothesis class, and I want to classify those fruits and also vegetables. So what does this shattering does? And I'm not going to label anything about the data set. What is the shattering concept does? When we break down these data set into subset without naming or without doing anything, the function present in the hypothesis, it automatically defines correctly, it automatically defines the function, or it correctly classifies them into different different subset. So here I have displayed one example which has 2 points, x1 and x2. So there are four possible labelings. That is, if you consider it as a binary classification, we have the combination. There are 2 points, say 0 and 1. So how we can map, or we can match these 2 points? There can be possibility of 0, 0, 0, 1, 1, 0, 1, 1. It's a binary classification. So this, consider this x1 and x2 is a hypothesis set H, and we have four possible labelings: 0, 0, 0, 1, 1, 0, 1, 1. So this is, if your hypothesis class produce a model for each labeling, then it has shatters into 2 points. So this is a concept of shattering. So then what is a VC dimension exactly? It is a hypothesis class which has the maximum number of points present in the class, which can shatter, that can shatter. Okay, if a model can shatter 3 points, say for example, if you can able to shatter 3 points, then your VC dimension value is 3. If a model can shatter 5 points, then your VC dimension value will be 5. So always it quantify the complexity of a model. Higher VC dimension means model is more complex, and if you have a lower VC dimension, then it will be easy to shatter. So formal definition of VC dimension, it is a hypothesis at H and the largest point that can shatter by H, and a hypothesis set H shatters a set of point S. For every possible labeling of the point S, there exists a hypothesis H that correctly classifies the points. In other words, a hypothesis set shatters a set of points if it can fit any possible labeling of those points. So we have understand what is the concept, what is the formal definition of BC dimension. You have a set H which scatters a set of point, and for every possible labeling, each possible labeling in point S, there exists a hypothesis H that correctly classifies the point is a formal definition. Thank you.